This is Algebra Lesson 5-1, Rate of Change and Slope. Rate of change is the relationship between two quantities that are changing. The rate of change is basically considered to be a fraction in which you take the change in the dependent variable and divide it by the change in the independent variable. The slope is the measure of the steepness of a line. It is also a rate of change, but it sometimes doesn't have any words associated with it, where a rate of change will be a relationship between maybe how much money you make versus how many magazine subscriptions you sell, whereas slope will be the measure of the steepness of a line. The slope of a line is its rate of change, which is its vertical change divided by its horizontal change, sometimes referred to as rise over run, which would be the change in y over the change in x. So if we're going to look for finding the rate of change, you can look at a table. That's the first way to look at something and seeing if you can figure out the rate of change. If I'm going to find rate of change using a table, the thing I'm going to look at is I'm going to look at the change in my vertical change, or my dependent variable, over my change in my independent variable or the x value. So in this particular case, we're going to look for the change in the fee divided by the change in the miles. So when we do this, we simply look at how much does the change occur in my y value, because remember, this is always x and this is always y. So here I'm looking at 30 to 42, which is a change of 12, 42 to 54, which is a change of 12, 54 to 66, which is a change of 12. In my miles, 100 to 150 is a change of 50, 150 to 200 is a change of 50, and 200 to 250 is also a change of 50. So if we're looking for the change in my fee, that would be $12, over the change in my miles, that would be $50, or excuse me, 50 miles. And then of course we're going to reduce this, because you always reduce all of your slopes or rates of change to lowest terms, but never changing them to a mixed number. So if I reduce this, I will end up getting 6 over 25. So it'd be 6/25, which would mean that my rate of change, because now I have to interpret this, 6/25 would be a slope, but it's not considered to be the rate of change because the rate of change needs to be in words. The rate of change would be $6 for every 25 miles. Okay. $6 for every 25 miles. So there's your rate of change. So for finding a table, whether it's X or Y, or whether it's in words like this one was, fee in miles, you can easily look at the change in your dependent variable and divide that by the change in your independent variable. Now from the data in the table, is this rate of change for each pair of consecutive mileage amounts the same? Which it obviously is. It's the same. It's a change of 12. And what does this represent? Okay. So interpreting your rate of change, this means that there's a $6 increase for every 25 miles you drive. So that would be how you interpret this particular rate of change. Now, this particular problem, if you look at it, if you graph the ordered pairs, miles and fees in problem 1, and they lie on a line, okay, which we're going to show on the graph I have on below here, the relationship between miles and fees is linear. And when data is linear, the rate of change will always be constant. So let's take a look at this. Let's graph this really quickly. So if we're going to graph this, first of all, I would need to label my little axes here. Let's label this one. My x-axis was, whoops, my x-axis, if you remember carefully, that was miles. And then my y-axis was the fee. So if I draw my two axes in here, so my x-axis here was number of miles. And this, my y-axis, was the fee. Okay, so if you looked back at the table, you notice that we started with 100 miles and we went to 150, then 200, and then 250. So I think counting by 50s would be really good. Okay, so if this is 0, this would be, I'm going to count by 25s actually. So 25, 50, 75, 100, 125, 150, 175, 200, 225, 250, 275, 300, 350 would be here, 400 would be here. That's probably good enough. And then the cost, okay, the first fee was $30 and it was $42. So I can think of, you know, seeing that the rate of change is consistently changing by 12, right? I could say, oh, I'm going to count by like 12s. I can make my interval on my y-axis be 12. So I can have $12, $24, $36, 42, 49. I'm getting off on my counting. 36, 42, 49, 54. No, not. I'm counting by 6s all of a sudden. Let's count by 12s instead of 6s. That's my error. So this would be 12. This would be 24, 36, 48, 60, and then we had, let's see. Actually, I think I do want to count by 6s because it's, sorry about that. I do want to count by 6s. So 6, 12, 18, 24. 6 times 5 is 30, 6 times 6 is 36, 6 times 7 is 42, 48, 6 times 9 is 54, 54, and then 60, 66. That's probably enough because that gets my numbers. So remember, if we were looking at my table, if I drove 100 miles, my fee was $30. So I have 100, and I'll go up to 30 here. And then if I did 150 miles, it was at $42. That's right there. And 200 miles was $54, which is right here. And then 250 miles was $66, which is right here. Okay, this is definitively linear, and of course the numbers between the values have definition. They are defined. The numbers between my values have meaning. So this is a linear graph. This is not discrete, it's continuous. So there's my lovely graph. And if you look at this, we can clearly see that my slope is going up 12, and it's going over 50. Up 12 over 50, up 12 over 50. So that is staying constant. Okay, the rate of change is constant. Okay, so this rate of change is obviously the slope of the line. Okay, so now not everything is easy to find the slope on by a table. Sometimes you need to look at a graph to find a slope. And you can either pick the points off the graph, or you can actually read the material off of the graph, which is what I'm going to do here on these first two problems here. If I want to find the slope using a graph here, I have a graph, and I have two points on the graph, which are definitively put in these blue dots. And what I'm going to do is when we read from left to right, when you read from left to right, whichever point you come to first, that's where you're going to start. So I'm going to start at this point right here. And I'm going to go down and to the right to get to my next point. So I'm going to go down here, and then I'm going to go to the right this way. If I count the number of squares I went down, 1, 2, 3, 4, 5, 6, 7, I went down 7. and I went to the right 1, 2, 3, 4, 5, 6, 7, 8, 9. So my slope then, right, my slope is going to be the rise or fall over the run, because it's always considered to be the change in vertical over the change in horizontal. So I went down 7 vertically and I went right horizontally. So my slope, which is abbreviated with a small m, which I'll explain in a minute, my slope is -7 over 9. Down 7 units, right 9 units. Down 7 units, right 9 units. Okay. If we look at problem number 2 here, I can do the same thing that I did before. Remember, reading from left to right, I'm going to encounter this point first. Now this time I'm not going down. In order to get to the next point, I have to go up and to the right. Up is positive, right is positive. So my slope should stay positive here. So if I count the number of squares, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. So my slope here is 4 over 6, which we need to reduce, which is 2 over 3. So my slope is 2/3. Now, it's handy to be able to read a slope off of a graph, and it's nice if you can plot the points and put them on a graph, but you don't want to have to put everything on a graph, because doing a graph could be really, really difficult. So notice that in the line in problem number 1 has a negative slope. Okay? This problem here, the slope is going down. You're sliding down a slide. Problem number 1 here, we're going down a slide. Here, we're going up a ladder. Okay, so problem number 1 has a negative slope, which means it goes down and right. When you read from left to right, we're going down to the right. Problem number 2 goes up to the right as you're reading from left to right. Okay, so notice that the line in problem 1 has a negative slope and slants downward from left to right, and the line from problem 2 has a positive slope and slants upward from left to right. Okay, so this leads us to the fact that you don't want to have to graph everything to be able to find the slope. You want to be able to compute the slope without having to graph points, because what happens if the points are really, really far apart? Do you have a piece of graph paper that can graph, -27, 482 as one point, and then the next point is 216, 2008? You don't want to have to graph that on a piece of graph paper. So you can use any 2 points on a line to find its slope. We use subscripts to distinguish between those 2 points. For example, x sub 1, y sub 1 are the coordinates of the first point, while x sub 2, y sub 2 are the coordinates of the second point. So x sub 1, y sub 1 just literally means the x value of the first point, the y value of the first point. X sub 2, y sub 2 means the x value of the second point, the y value of the second point. And the slope formula is rise of a run, and it can be y2 minus y1 divided by x2 minus x1. Y has to be on the top, x has to be on the bottom. And x2 minus x1 cannot equal 0. We'll talk about that. And the abbreviation for slope is m. And I told you I would tell you what that stands for. You have to know that there are many different mathematicians in the world, and not all of them were Americans. Okay? The Cartesian coordinate plane, which is what we call the x and y axis, was first invented and used by a man named René Descartes. René Descartes was French. So when we talk about slope, they don't use the word slope. So it would be really weird for them to use the abbreviation S for slope. For them, the word that represented slope was called montier. It means to mount, to go get up. Okay, like mount a mountain or mount a horse, you're going up to it. So that's why they use an M for the abbreviation for slope. So we will use an M for our abbreviation for slope. The one thing you have to pay attention to is you have to pay attention to the fact that no matter how you write your formula, these two have to have the same subscript, as well as these two here have to have the same subscript. I can't do y2 minus y1 divided by x1 minus x2. They have to come from the same coordinate point, okay? And they have to be in the same order. So if I've given you 2 points and I ask you to find their slope, to find a slope using 2 points, we're going to use the formula, okay, the slope formula, where y2 minus y1 over x2 minus x1, or it could be written this way. You could have y1 minus y2 over x1 minus x2. You just have to make sure you get them in the right, If you have y2 starting on the top, then you have to have x2 starting on the bottom. If you have y1 starting on the top, then you have to have x1 starting on the bottom. Just make sure they're in order. That's all I'm meaning on that. Now, the easiest way to make sure that you're taking x values with x values and y values with y values, line up your points. I've given you these horizontally, but I'm going to rewrite them vertically, like this. So now, my x values line up with my x values. Here's my x values, and here are my y values. So I can line them up when I go to use the formula. So now if I use, I'm going to use y1 minus y2, I always do. If I use the formula for slope, I'm going to have my y values 2 minus 9 over my x values 2 minus 8. Okay, so I'm doing 2 minus 9 divided by 2 minus 8. Well, 2 minus 9 is negative 7, and 2 minus 8 is negative 6. Pay attention to signs. That's one of the biggest things that people have trouble with slope. Well, negative divided by a negative is a positive, so this is 7/6. Do not change this to a mixed number. Don't change this to 1 and 1/6. Slope is never a mixed number. It is an improper fraction or it is a whole number, but it is never, ever, ever a mixed number. So the slope between these 2 points is 7/6, and I didn't have to graph them, which makes it a little bit easier to do, especially if you have a lot of points. Okay, let's look at the second set of points here. Let's say I have negative 1, 4, and I'm going to rewrite 3, negative 2 right below it. And I'm going to do my change in y, so I'm going to have 4 minus a negative 2. Be very careful with your negative signs. And then I'm going to have negative 1 minus 3. So 4 minus a minus 2 is actually 4 plus 2, so that is 6. Negative 1 minus 3 is negative 4, and negative 6 over negative 4 reduces, and it doesn't matter where the negative sign is as long as I only have 1. In my problem, to make my slope negative, I need to have 1 negative sign. It can be in the numerator, it can be in the denominator, or it can be in the middle of the fraction. I have a tendency to always put it in the numerator just in case you wanted to know that. So 6 divided by negative 4 reduces to negative 3 over 2. So there's my slope for that problem. So that's how you find the slope using 2 points. Now, sometimes you're going to get what we call horizontal and vertical lines, and you need to know how to find the slope of a horizontal or a vertical line. If we look at this first example here, this is a horizontal line. Remember, the horizon goes left and right. If you look at this, we could pick any 2 points on this and figure out the slope. Okay, so I could decide, okay, I'm going to pick 2 random points. Let's pick this point here, and let's pick this point here. This point happens to be negative 3, positive 2, and this point happens to be positive 2, positive 2. So I could figure out the slope by using the slope formula. So I have negative 3, 2, and I have 2, 2, and it'd be my change in y, so 2 minus 2 over my change in x, negative 3 minus 2. So I would have 0 over negative 5. Well, whenever I have a 0 in my numerator, when you reduce that, you always get 0. Okay. The slope of a horizontal line is always 0 because you're not rising, you're only running. You're not going up or down, you're just going left and right. Okay, so the slope of a horizontal line is always 0. Do not say no slope. Say 0 slope. Okay, it is defined as having 0 slope. If we look at a vertical line, like number 2 here, number 2 is definitively a vertical line. It's going up and down, which is vertical. And they've picked 2 random points, and those 2 random points happen to be negative 1, 0. And this one happens to be negative 1, negative 3. So if I was going to do the slope of that, I would have 0 minus a negative 3 over negative 1 minus a negative 1. Well, 0 minus a negative 3 is a positive 3, and negative 1 minus negative 1 is negative 1 plus 1, which is 0. Whenever you have 0 in the denominator of a fraction, your answer is not 0. Your answer is undefined. Okay, so 3 over 0 actually equals undefined because you cannot define that. Division by 0 is undefined. Okay, so the slope of a vertical line is always undefined. Okay, the slope of a vertical line is always undefined. Because we're always rising and never running or falling. Okay, so the slope of a vertical line is undefined. Every slope of every vertical line will always be undefined. So let's take a look at finding the slope between these 2 points right here. Okay, if I have 4, 2, and 1, 2, again, I'm going to write them right underneath each other so that I can line up my x values and line up my y values. My change in y would be 2 minus 2 over my change in x, which is 4 minus 1. Well, 2 minus 2 is 0, 4 minus 1 is 3, so the slope of this line is 0. So it must be, excuse me, it must be a horizontal line. Number 4 here, if I was to rewrite the points right underneath it, which I highly suggest you do because it keeps your points straight. Change in y, 2 minus a negative 1 over the change in x, 4 minus 4. 2 minus a minus 1 is 2 plus 1, which is 3. 4 minus 4 is 0, which means this slope happens to be undefined because division by 0 is undefined. So we know that this line is a vertical line. These 2 points constitute a vertical line. So, quick little summary here. Nice visual. A line with a positive slope slants upward from left to right. As you read from left to right, it's like you're climbing up a ladder. A negative slope slants downward from left to right, which means it's kind of like sliding down a slide. A line with a slope of 0 is always a horizontal line, and a line with an undefined slope is always a vertical line. Okay, so this gives you a great way of understanding and visualizing slopes. Okay, we are going to do an awful lot with slope this chapter, so the sooner we learn all the different ins and outs of it, the happier we'll all be. All right, your closure question for today. What methods can you use to find the slope of a line defined by 2 given points? So what methods can you use? Methods, notice that's plural, so please answer it in a plural answer. Don't give me one method, give me at least 2. Okay, so what methods can you use to find the slope of a line defined by 2 points?